Hey guys. So today what we're going to do is move on to our third day of solving these trig equations. So I know yesterday we talked about like reviewing non-special angles and using our calculators in order to find them. So what we're going to do today is we're going to kind of take it back to the two lessons that we talked about before spring break about just getting sine, cosine, and tangent by itself, finding those angles, and then going from there to solve the trig equations. We're going to combine that with our whole idea of non-special angles that we just talked about yesterday. All right. So all of these problems that we're going to go over when we solve these trig equations, they're going to end up involving non-special angles at the end. All right. So let's look at the first one. So if you guys are looking at number one, you have 7 times sine of x minus 4 is equal to 0. So if you remember what we were doing before spring break, we talked about solving these trig equations by always getting that trig function by itself on the left side. So if I look at number one and I want to get this one by itself, that means I'm going to have to add 4 to both sides. And then I'm going to go ahead and divide by 7. All right. Okay, so once you guys get to this step, which is what we've done before in the past, this is what you guys want to now like try to identify. All right, am I working with a non-special or am I working with a special? Well, obviously today we know we're working with non-specials, but what you want to look for or look at is you really want to look at this 4/7. And you want to think about that fraction. Is that something that looks familiar, like a 1/2 or a √3/2, or is that something that looks completely like out of normal? So if you look at 4/7, since that's something that we don't know and that's not a part of any of our special angles, those ordered pairs, this means that I'm working with a non-special angle. Okay, so the second that I know that I'm working with a non-special angle, we're going to do exactly like we did yesterday, where we have to find our reference angle, then find a quadrant, and then that's going to lead us to our two different answers. So it's going to be really hard for me to bring up the calculator and do this at the same time. I just wouldn't have enough room. So I'm going to kind of write what I would put in the calculator. But in order to find your reference angle, you guys would type in and you would find the inverse of sine of 4/7. That's what you guys would need to type in your calculator. And that would give you a reference angle, making sure you're in radians, of 0.608. Now, when you go back and just like we talked about, when you go to identify what quadrant you're in, remember, you're really focused on this step right here. Since you're working with sine and this 4/7 over here is positive, that tells you that your y value needs to be positive, which is true in quadrant 1 and 4. So when you guys go through and you solve for x, let me just switch this back to red. But when you go through and you solve for x in this case, using your reference angle in quadrant 1, well, we know anytime we're in quadrant 1, it's just going to be our reference angle. So 0.608 is one of my answers. And then if I go to quadrant 2, I just have to take pi and subtract my reference angle from that. And that would give me 2.534. So those would be my two different answers in quadrant number 1 and quadrant number 2 for problem 1. All right, so like I said, it's really similar to solving those trig equations that we talked about before spring break. It's just now that last step is using your calculator to get a reference angle instead of knowing the special angle that you're working with and going from there. All right, so let's look at number 2. All right, so on number 2, you guys have something similar, but you have 9 times cosine squared x minus 1 is equal to 0. So the same thing's going to happen like we did on number 1. You guys want to try to get this cosine x by itself on that left side before you go through and use your calculator. So in this case, I'm going to add 1 to both sides. And then divide by 9. All right. Okay, so just be really careful when you guys are at this step. I know these two steps look similar, but just know that this is a cosine squared x. It's not cosine by itself. So we need to get it by itself, which means we now need to take the square root of both sides. So that's what's going to get you to just have that one cosine x by itself on that left side. Just remember, when you're taking the square root, when you're solving an equation, you always need a plus minus sign. All right. Now the square root of 1 is just 1, and the square root of 9 is 3. So you end up getting that cosine x is then equal to plus or minus 1/3. All right. Okay. So now that you're there, remember, don't really worry about the sign. Like the 4/7, that sign's going to really come into play when we start thinking about our quadrants. But when you guys go through and you're using the inverse of cosine to find that reference angle, you're just going to type in your calculator the inverse of cosine of 1/3. Don't worry about the plus minus sign yet. And when you go through and you do that and you get your reference angle, I ended up getting a reference angle of 1.231. Okay? All right. So now that you have that reference angle, remember the next step, like we talked about, was figuring out what quadrants we're in. Well, like on this problem, since we know that sine was equal to a positive value, y was positive in quadrant 1 and 2. The only difference was if you look at this problem, this is when this plus minus really kind of plays into this. You're really focused on cosine, which is x, is either positive or negative. So if we're looking at our quadrants, well, x is positive in quadrant number 1 and quadrant number 4, but x is also negative in quadrant number 2 and quadrant number 3. So because of this plus minus down here, that actually means that you're representing or you're in all 4 different quadrants, and that's where your answer is going to lie. All right, so let me just switch a color so answers don't get too jumbled in with everything else. All right, so when you go through and you're solving for x, well, if we're just worried about quadrant number 1 for right now, I know quadrant number 1 is going to give me an answer of 1.231 because that's just my reference angle. Quadrant number 2, I'm going to take pi and subtract that by 1.231, which is going to give me 1.911. In quadrant number 3, I'm going to take pi and I'm going to add 1.231 to it. That'll give me 4.373. And then lastly, quadrant 4, I'm going to take 2 pi and subtract 1.231 from it. And that's going to give me 5.052. So you end up getting 4 different answers in this problem, but that should make complete sense because you are in 4 different quadrants, and each quadrant has its own angle that goes with it. So you would end up with four different answers for problem number 2. Okay. All right. So then the last one that we're going to go over is number 3. And number 3 might look a little bit tougher, but if you guys remember from before spring break, it's actually not too bad. So for number 3, you have tangent squared x minus 2 times tangent x minus 15. And if we were to compare that to something back in like algebra 1 or algebra 2 that we were like looked familiar, it's the same exact thing as having an x squared minus 2x minus 15. It's the same exact start. So I know you can't get tangent by itself because you see a tangent and a tangent squared, but this is really just telling you that you're going to have to factor. And if we were to factor something like this back from algebra 1, well, we know we would just start each parenthesis with an x, factors of 15 to give us 2, are 5 and 3, and the 5 would have to be negative and the 3 would have to be positive, right? And that would be it. So when you guys are looking at problem number 3, it's really similar. You know you have to factor this because you have a tangent squared and a tangent to the first in there. So there's no really way of getting it by itself. So when you do factor this, that tangent squared, that's what's going to split up into just a tangent of x to start each parenthesis. All right. You're still looking for your factors of 15 to try to give you that 2 in front of tangent in the middle, which we know are 5 and 3. And then since that 2 is technically negative, the 5 would have to be negative and the 3 would have to have a positive sign in front of it. So this would factor into tangent x minus 5, tangent x plus 3. Okay, so once you guys have this factored, again, just a little refresher. Now you're going to set each one of these groups equal to 0 and solve by getting tangent of x by itself. So I'm going to have tangent of x minus 5. I'm going to set that equal to 0, and I'm also going to take is tangent of x plus 3, and set that one equal to 0. So when we talk about solving, remember, you're just trying to get tangent by itself on that one side. So I'm going to first focus on this left side. So by getting tangent by itself, I'm just going to add a 5 to both sides, and that's going to give me tangent x is equal to 5. Now, just like the two problems that we did up top, once you guys have that trig function by itself, that's it. Now you have to determine, all right, am I working with a non-special or am I working with a special? Well, since you're looking at 5, and 5 looks something that's like really unfamiliar, again, you know you have to be working with a non-special angle. So in your calculators, you guys are going to find that reference angle by doing the inverse of tangent of 5. And when you do this in your calculator, that's going to give you guys a reference angle of 1.373. All right. Now, just focus on this side. If we think about next, after we find that reference angle, let's think about our quadrants that we're in. So again, looking up here, since tangent x is equal to a positive 5, that's saying that y over x is positive. So we know that y over x is positive in quadrant number 1 and quadrant number 3. So if I want to go through and I want to write my final answers, and I'll write them on the bottom. So far in quadrant 1, I have 1.373. And then in quadrant 2, when I do pi plus 1.373, I end up getting 4.515. All right. Okay. So those two are definitely a part of your final answer, but it's not like you're not finished. You're not done everything because there's still this right side over here that we have to worry about. So the left side's done, but now we just got to go back and focus on that right side. So when I go back and do the right side, I'm going to do the same exact thing. I want to get tangent by itself, so I'm going to go through and I'm going to subtract 3 on both sides. So I have tangent x is equal to a negative 3. And at this point, I know that I'm working with a non-special because negative 3 doesn't look like any complex fraction that looks familiar to me. So I'm going to use my calculator. I'm going to find my reference angle by doing the inverse of tangent. Now remember, since it's equal to a negative 3, we're not worried about that negative. So in our calculator, we're just putting the inverse of tangent of 3. And that's going to lead us to our reference angle, which is 1.249. Okay, so now that you're there and you found that reference angle, now you got to go back and figure out what quadrant you're in. And this is where that negative really matters. So when we're looking at this set to figure out my quadrants, remember, this 3 is negative, which tells me y over x is a negative value. And y over x is negative in quadrant number 2 and quadrant number 4. So using my reference angle and using my closest x-axis of pi to find quadrant number 2, I just kind of add this onto my answer. Quadrant number 2 is going to be 1.893 because I'm just taking pi and I'm subtracting my reference angle of 1.249 from it. If I got to get quadrant 4, I do the same thing, but now I'm taking 2 pi. So 2 pi minus 1.249 gives me a value. I'm going to have to write this up here a little bit, but 5.034. All right. So then in this case, I would have 4 different answers because I was, again, in 4 different quadrants on the left and the right-hand side. All right, so if you guys have any questions on this stuff, let me know. Hop on that Google Meet session later today. Even if it's stuff with a calculator, it's going to be really easy to help you guys out. So just let me know if you have any questions and then complete that assignment today and submit that by midnight. All right, thanks, guys. Have a good rest of your day.